Hey, Dr. Ko. Now we can move on to the code. So first we're going to import our functions. That's for the main function, and this will help us plot all of our B arrays on the plot. And now we're going to import the SciPy linear algebra solve banded to help solve for the unknown temperature. Okay. Now from here we're going to import. We're going to make some variables. So our length of the bars, we're going to call it nx. That's 50 for 50 meters, and then nt, that'll be our time. We want to check every 5 minutes for an hour. So in this, it would be 3,600 seconds. Now our t, that's going to be a temperature array. We're going to make that. It'll be np full, and the initial value is 20 degrees Celsius for the entire bar. So it'll be 50 meters long. So the array will also be 50 units long, and then it'll be all at 20. So that'll give us a temperature array of 50 20s. Now that we have this, we can set our initial temperature of the left side of the bar equal to 50. And now if you look at this, we'll have T equal to 50, but only at the very left side. Now we can incorporate, or we can put in the thermal diffusivity, and that's 1. Now we will incorporate delta X, and that's also equal to 1. That'll be going 1 meter at a time across the bar. And then we also have delta T, and we'll be going once every second. So that'll also be 1. Now we can move on to a few more arrays. X is going to be equal to, this will be our X array, like the steps that we take across the bar. That will be 50 units long, or nx in this case, and then that'll be multiplied by delta x. In this case, it's just multiplied by 1 because it'll be 50 units long. So that'll give us a x. And that'll give us stepping one meter at a time. Now we have our r, and that will be, we solve for this in the derivation. Delta t divided by 2, that's for the average, and then divided by delta x squared. Now that we have this, we can make our array for 0. This will help us solve we'll put this into the solve banded equation, line of code, so we can solve for the unknown temperatures. We're going to start it at everything at 0, and it'll be a matrix. It'll have 3 rows, and it'll be length nx minus 1, so it'll be length 49. So that gives us a matrix with 3 rows, 3 separate rows, and then nx 49. So now we're going to fill in the first row, which will be into 0. And it'll be everything except for the first one, because we're shifting it. We're shifting the diagonal like this. Now that we have that, it'll be everything except for the first one, and they will be negative r, like we saw before. Now we will do the second row, and that will be indice 1, and then that will be from the beginning until right before the last one. That'll be equal to 1 plus 2 times R like we solved for. Now we will move on, and this will have, it'll be in the same row, the second row, but it'll be just the very last indice in the second row. And that will be just 1 plus R, like we solved for in the other code. Now we have our very last row, and this will be everything except the very last. And this will be equal to negative R like we found. So if we take another look at A, we will get, there will be a 0 placeholder here, a 0 placeholder at the end of the last row, and then everything is equal to 2 in this case, and then the last row is the only difference. So now we can, we'll start with our figure. We're gonna plot our initial temperature line. Now, once we have this, we will get to see what the bar looks like at the very beginning, temperature of the bar at every length along the bar, right as it's heated up. T, and then it's the initial, so we're just going to name it initial. There we go. And now that we have that, run it. Plots. Run it. And now we can see the first part of the first measurement of the temperature of the bar. The left side starts at 50 and then goes all the way there. So now that we have that, we can move on to our loop, and that we're gonna do it for I in range 1 nt for our number of seconds plus 1. We have to go 1 further or it won't count the very last one. So now that we've got that, we can move on to our B. So the B, we're going to make it the same length as A, and we're just going to make it zeros for now. And it'll be nx minus 1 for the same length as the rows in A. So now that we have that, that's obvious. Now we can start with B. So for the general equation for B, it'll start at 0 and it'll go all the way until the very last value. So it'll be colon -1 for that. And it'll be equal to R times T, and then this is the colon -2 is like the J minus 1. It'll be the temperature to the left. And now it'll be plus 1 minus 2 times R for the current temperature. So that will include the temperatures starting at 1 and then going all the way to -1 right before the end. And then you will add R, and then that'll be multiplied by T, and that will be the temperature to the right. So that'll include all the values to and then to the very end. So now that we have that, we can move on. Now the initial temperature is different. It will be, like we solved for, it will be obviously the B is 0, and then we also have to add R times T at 0 because we know what that is. That's where we moved it to the other side. Now, we also have to change the final, and that will be the b at -1, the very last value, and that will be r times T. That'll be the temperature, the second to last temperature, and then from there we will add 1 minus r like we showed, so we can calculate it, and then it'll be times T, and then it'll be the very last value. So now that we have that, we have all our values for the B filled in. Now we can, let's actually, yeah, so it checks out. Now we will incorporate the every 5 minutes. So I'm going to say I, and then if the remainder, 300, because that'll be every 5 minutes in seconds. That's equal to 0. Then it's going to add that to the scatter. It'll add that to the plot. So T, and then and that will be name, and then we're going to name those equal to, those will just be whatever indice it is at the time. So we have that. We can add in the figure and see what we get. Okay, let's see what we went wrong. So I forgot to solve for the T's, of course. This will be, we're going to go from, you don't want to include the very first temperature value because we know what that is. So we're going to have to go from 1 to the end, and that will be where we incorporate the solve banded. So here, it'll be 1, 1 for the one diagonal above and one diagonal below in the matrix, coefficient matrix, and then we have our vector A and our B. So now that we run this, we will get the graph that looks like that, just like your problem. Can't believe that it was a simple, small mistake, but what else are you going to get in the coding? Thank you for a great class, Carlos. Really enjoyed my time. I learned a lot, and it's all thanks to you. See you in class soon.